Morning, YouTubers. Today I got a video unofficially sponsored by Quick Trip Coffee. I don't know if you guys got Quick Trips by you or Quick Stars, and I think they own another company, but their coffee is as good as crack, at least to me. Their food, I don't know, people say their food's good, food's trash. I don't like it. Especially their chicken, people love that. I don't know what's in that chicken, but nasty. So today's video, we're going to be talking about silicon and aluminum bronze. Now, a lot of you guys out there don't have much experience with TIG brazing, as it's called, so I figured why not shoot a video and talk about it. So that's what we're going to be doing today. Let's get into it. So I have a couple different types of brazing rods that I want to cover. There's two main types that you're going to use for TIG welding. One is known as silicon bronze, which I have here, if I can get it to focus. There we go. 1/16, I have 045 N 3/32. And then there's aluminum bronze. Aluminum bronze. And then of course you have zinc bronze. This is primarily used for torch welding. We are not going to use this with TIG. Easiest way to identify that this is a type of bronze that it is for torch, look at the white flux on there. If it has flux on it, you don't want to be using it with TIG. That's for torch brazing. So I eliminated that out of the stack. So this is really what we got to deal with TIG. Now I'm going to preface this whole lesson. Brazing, welding, whatever you want to call it, with bronze wire isn't the greatest for your health. And I'm going to be honest about that. I mean, welding in general isn't the best for your health, but using this stuff, probably should be wearing some kind of respiratory protection. You get it. I'm not your head of safety here, but be smart about it. Don't be breathing this crap in. So we'll start out with the silicon bronze. Silicon bronze works with steel and cast iron and stainless. You can also silicon bronze titanium. You can bronze all sorts of stuff. With this product, you're technically not welding. You're brazing. Quick details on that. Essentially, with welding, you're melting the base material. So your filler melts and your base material melts, and you create an alloy known as a weld. With brazing, you're not melting your base metal, you're only melting the filler, and essentially it works in a way like, I guess, glue of sorts. It's a lot stronger than glue, it's a lot stronger than JB Weld, and a lot stronger than soldering, which soldering is similar to brazing. Much, much stronger than that. I mean, you'd actually be shocked at how strong silicon bronze actually is. If you put enough of it down, it would arguably be as strong as a weld is, depending on joint configuration. Something to think of. Now, aluminum bronze is stronger than silicon bronze. It's a little bit harder to work with. We'll be doing a whole separate section of this video just on that. So let's just start practicing with some silicon bronze. Here are some spec sheets for those fillers that I'm using. It's from Washington Alloys. Look at their website if you ever want to find out specs for a particular wire or rod. They're really good about it. So here you can see that the settings are all based on what diameter wire you're using. It also mentions a preheat on, looks like 600 or 4 to 600 for cast iron, which that would really help it wet in a lot better because cast iron tends to be thicker and the toes won't wet in that well. So good ideas there. This sheet here talks about the actual physical testing of this wire, and you can see a tensile strength is 50,000 psi. Now this spec sheet is for aluminum bronze. I'm using A2. I'm not quite sure the difference between them, but I'm sure Washington Alloys would have sheets on the other ones. You can see this is commonly used to repair ship propellers, pump housing, piston heads, all sorts of stuff they list. I personally use it mainly if I need something that I can't really weld Aluminum bronze will stick, and I need more strength than silicon bronze. Works good for that. Here you can see the actual testing, and clearly the tensile strength is much higher than silicon bronze, so overall it's much stronger. It also has a higher hardness. And as you notice, the elongation is much lower. Interesting things to think of. All right, so here's the setup. I got a big thick piece of channel, C-channel. I just buffed this end off. The rest of it's still rusty and it's still wet from being outside. That's all right. I highly recommend you dial in your brazing technique on a piece of scrap before you start doing test joints, because this stuff isn't the cheapest, nor is metal anymore. So you really want to maximize your skill before you get into actually like using fresh new metal. So this is roughly a 1/4 inch thick. The thickness doesn't really matter because with brazing, you're going to operate within a certain heat window. Now I'm using 1/16 brazing rod. I'm going to be using obviously TIG welding. My setup is a gas lens with a 3/32 tungsten. I believe this is a number 8 cup. Yeah, it's a number 8, about 15 cubic feet an hour of argon. Now my machine settings are 80 amps, which under conventional sense you would not weld 1/4 inch thick steel with 80 amps. The keen among you remember, we're not welding, we're brazing. So this brazing rod operates at a lot lower of a heat input than welding. So 80 amps should be the ballpark of the start of where we would want to be at for brazing. Now we can go up from there, but it's obviously going to be a lot less than steel. So what I'm going to do here, I'm going to run a couple inch long bead and we're going to look at it. I'm going to be doing lift arc start with a foot pedal for control. The reason is that the high frequency on my welder and pretty much all TIG welders interferes with my wireless microphone. Otherwise I would be using high frequency start. So let's get going and run a pass and talk about it. So I'm just going to give a little overview here at the start and then I'll shut up. The travel speed I'm going to travel at is going to be pretty slow. I could increase the amperage and go a little faster, but it's kind of a risk you take of diluting your base material into the bronze. You don't want that. So I tend to take my time. The other thing worth noting is the arc tends to be green in color depending on your heat settings and your arc gap. You can see it kind of looks like a normal weld, a little bit discolored. You can see it was colder at the start. I couldn't get enough amperage. But 80 amps is enough to flow this out and would be a very appropriate training amperage. Now I find with bronze is best off that you just set the machine for a particular amperage, like say 80 amps, and then just weld with it. And you want to keep that arc of your TIG torch right on top of the filler. You do not want to move that arc in front of the filler on the bare plate. You want to just keep it on that filler and slowly drag it, because the idea is to melt the bronze wire and the filler here, not the plate, because you want to attach it to it. The more dilution you get of this base metal into the filler, the worse off it's going to be. Now let me grab a brush here and show you. Most of that was just soot on there. If I wire wheeled it a little bit, it would come out even cleaner. You get some discoloration from the heat affected zone, but again, overall, looks just like a, kind of like an aluminum weld or stainless weld with the way that it appears, the real roundness of it. But there we go, let's do a couple more tests and then we'll talk a little bit more about how to do this. There you have it. fix the cold start a little bit. You can tell a little bit colder there than it is there, but overall, very much like welding. Very similar. One of the tricks that you want to do in order to weld with bronze, when I start the arc, I'm increasing the heat until I see the smallest molten diamond you can have. So, like, I'm not looking for the molten pool to get as wide as a normal weld bead. Like, essentially right as that molten pool appears is like a pin dot. I get the bronze ready, dab it to that pin dot, and I slightly increase the amperage. And once that this bronze melts off and kind of makes roughly a dime shape, that's the amperage I want. Which these were both pretty much full pedal 80 amps. That's about what you need for this to run a bead on plate, is about 80 amps. So you just drag that molten dime along and keep adding filler just like you would on a TIG weld. The actual process of it isn't that much different than just running a bead on steel. It's just that I'm at 70 to 80 amps peak, versus to weld on this thick of steel with TIG and get that wide of a weld, I'd need to be at, I don't know, 120 amps, so significantly higher. So it's very much like welding with normal filler, just at lower amperage. What you want to be careful of is that welding like actual lap joints or fillet welds, if you run too much heat and start melting off the metal into this, first off, the color of it's going to be terrible. The strength of it's going to be subpar. You don't want to dilute any filler or any base metal into this filler. All right, so here's the setup. Got a lap weld here. I'm going to braze this side of it, let it cool, flip it over, braze the other side, and then we're going to take a look at it. Now, if you look at that, it looks kind of like a scaly mess. We're going to wire wheel that up a little bit, or at least brush it off, and then take a look at it. All right, let's actually look at that. So this was the first side, still a little bit hot. You can see by the toe line on the lower end, it's a little bit not wetted onto it as good as it should be. A little bit cold at the start. Started flowing out pretty good. Not too bad. The second pass I did turned out a lot better. Almost too much amperage. I started cutting into the steel up on the top, but not too bad. The best way I can describe the way this runs is you have to push a lot of filler, kind of like with aluminum. It almost, when you're TIG welding, it seems to be more like aluminum than steel. That's the best way I could describe it. But the toe line on the second pass, being that these were preheated a little bit, definitely wetted in a lot better. And honestly, that has more to do with the plates being hot than it does anything else. I mean, I did hold a slightly tighter arc on this side, but just having it warmed up a little bit helps tremendously. So if you really have to make a nice aesthetic bronze TIG braze, you might want to just torch heat your plates or parts just a little bit, not a lot. Not bad. I'm going to cut and etch this just so we can take a look at it to demonstrate the penetration, or should be lack thereof, on this. All right, so the cool thing with this stuff is you don't need to etch it because you can clearly see the results. Now, the first pass that was a little bit colder, just judging by the lack of wet out on the lower piece. If you look at that, and I'll flip it for you, you can see essentially none of the base material is really melted off, and I'll post a higher detail picture here. There's no root penetration, there's no penetration into the bottom plate. Now the hotter pass right here, you can see it kind of nipped the top edge of that plate. Now some of that may just be because of how it was rounded off, but I was running a little bit on the hot side and chewed that top plate a little bit. But again, you can see absolutely zero penetration. It just sits right on top of the steel, and that's what you ideally want. All right, so with the silicon bronze covered, let's talk about the other common one, or I guess less common, but aluminum bronze. So aluminum bronze, the filler looks a little bit different. It has aluminum in it. It functions a little bit different. Aluminum bronze is also stronger than silicon bronze. So that may or may not be a help depending on what you want to do with this stuff. So there's two ways to run aluminum bronze. You can run it DCEN, so standard TIG, or you can actually weld this stuff on AC on normal steel, stainless, whatever. We'll start out with the DC. I'm going to run a couple beads on here just with DC, and we're going to compare them to the silicon, and then I'm going to run a couple on AC, and then we're going to compare those, and we'll talk a little bit more about it. I'm going to weld with this, or braze with it, at the same amperage that I did with the silicon bronze, and we're going to look. If I need to bump the amperage up a little bit or down, I will. All right, I'm gonna have to bump up the amperage slightly. It's a little bit too cold to work with this, so that's what I'll do right now. Let's take a peek here. Now, right away you can tell there's quite a bit of a different color to it. So silicon bronze will turn goldish, copper, little bit of tint to it. Aluminum bronze comes out pure gold when it's shielded with enough argon. Now you can see this, I just didn't have the amperage. I bumped it up about 8 amps to 88 amps to weld this second pass or braze the second pass. You have to have a little bit more heat, I find, with aluminum bronze than silicon bronze. Now this looks okay. And you can tell by the heat affected zone, by the tempering colors, a lot more heat went in to get this braze to flow out. It's very sluggish. Now that's one way you can braze with this, is on DC. I'm gonna weld or braze with this stuff on AC now. I know that sounds counterintuitive to weld or braze anything on steel on AC, but trust me. So it's gonna sound a little crazy, but let's do, okay, AC lift TIG. For AC frequency, I'm just gonna put it at 60 Hertz. AC balance, we're gonna do something that you would never normally do, and that's 90% AC balance. So that means 90% penetration, 10% cleaning. Now you would never be able to do that on normal aluminum simply because that's not enough cleaning to get a decent weld down. But with this stuff, it'll work a lot better. Now, I bumped the amperage up a little bit to 100. I'm not sure how much of that 100 I'm gonna use because I don't weld with aluminum bronze that much, but we'll see what happens here. Now, if you look at that, it comes out like pure gold. You can see our heat input a lot less. Our bead width is actually bigger. Now, I did weld this at 100 amps full pedal. So that's about where you want to be at. Since your weld or your braze bead is a lot wider, you're going to need a little bit more heat because you're flowing out a lot more of the material. Now, one of the unfortunate things is with aluminum bronze is that if you excessively clean it with a wire wheel, now you don't see it here, but you can wear away that bronze layer on it, and then you just have a silver, what appears to be a silver weld, and that's the aluminum essentially is inside of this. So I'm not an expert in how this works, but I believe that the bronze is what sticks to the steel, and then the aluminum essentially stays inside of it, surrounded or coated with the bronze, which means if you wear through the bronze, you just have the aluminum inside of it. Because you can't obviously stick aluminum to steel, but aluminum to certain types of bronze will stick. So I believe that's what's going on. I'm not an expert, but it's just a thought. But like I said, you can easily wear through that coating on there, and then rather than being gold, it just comes out silver. So let's do an actual joint with this and take a look at it. Thought I would just share that because how beautiful it looks. Kind of cool. Now it was running a little bit hot. It started to spit some of the aluminum from the bronze back onto the tungsten, which you can only run so tight of an arc gap with it because of that. But overall, the bead appearance is pretty decent. I'll try and hold a little bit longer of an arc and a little bit less amperage on the next pass, but isn't that cool? Near the end there, about, I don't know, a fifth of it left, I ended up pulling the rod out and the rod stuck to the plate, and I tried to break it off and then of course dipped my tungsten. I try not to edit out stuff like that, so, well, for one, you can see that I make mistakes and I'm human, and two, that you can recover from mistakes. It's not the end of the world. So let's look at this. So again, you got that rich gold color. About right here, I dipped it. Whoops. Like I said, if I were to clean this, it generally doesn't have much effect on it, and you'll just wear through it pretty quickly to get to aluminum. All the pretty colors are gone now, other than the braze itself is still the golden color. But there you have it. You can tell that that wetted out a little bit better. And that's aluminum bronze. I generally use silicon bronze for most things. If it's something that needs more strength, aluminum bronze will help. And it does look a little bit better, I'll be honest. There you have it. If you want to see me do any more videos regarding this or have any questions, feel free to leave them in the comments. Otherwise, thanks for coming along in this video and learning some stuff and hopefully learning from my mistakes. Thanks.